Hello students, today we are going to talk about internal resistance of a cell. Now before starting with the topic, if you want to improve or excel in maths and science, do check out the micro courses offered by Infinity Learn and don't forget to use the coupon code HQ10 for additional 10% discount. Now coming back to the topic, if I have a cell like this and if we connect it to a circuit whose resistances are, there will be a flow of current through the circuit, and the direction of this current is from higher potential to lower potential, or from positive terminal to the negative terminal, from outside the cell through the external circuit. Talking about the charges which have reached over here at the negative terminal, these charges will travel from the negative terminal to the positive terminal as ions, and while flowing through the electrolytes which are present in this cell, they experience resistance, and this resistance is nothing but the internal resistance of the cell. So generally a cell is denoted by a symbol like this, with one terminal positive and other one as negative. But in practical cases, all the cells have internal resistance, and the internal resistance is denoted by small r. So this is the representation of a practical cell, where the cell is having EMF E and internal resistance R. So to conclude this, the resistance offered by the electrolyte inside the cell to the flow of current is nothing but the internal resistance of the cell. Now being a type of resistance, the unit of resistance is ohms and the symbol is omega. Now when we draw current through this cell, there is this current I flowing through the cell internally as well, and there is this voltage drop inside the cell due to the internal resistance. Let us denote this by small v, and this will be equal to I into R. Now let us go ahead and find out the relation between EMF, terminal voltages, and internal resistance. Let us consider a cell which is having EMF, internal resistance R, and it is connected to an external resistance denoted by capital R. There will be a current which is set up in the external circuit. Let us denote it by I. We know the current will be nothing but EMF divided by the total resistance. Now the total resistance is capital R plus small r. Therefore we have EMF of cell given as I into capital R plus small r. Now once we open the bracket over here, what we have is I into capital R plus I into small r. I into small r, as already discussed, it is nothing but the voltage drop due to internal resistance, and I into capital R will be the voltage drop across this resistor, or you can say it is the potential difference that we can find across the terminals of the battery, which we can denote by capital V. So small v can be written as EMF minus potential difference across the battery. So capital V is potential difference across the terminals of the cell. Now finally, if we talk about the internal resistance R, so internal resistance R will be given by small v, voltage drop across the internal resistance due to internal resistance, divided by current, and this can be written as EMF minus potential difference across the terminals of the cell divided by the current I, and current I can be written as V by R as well. So we have used two relation. One, we have used ye wala relation. Second, we know small v is equal to I into R. So from that we have written small r ka relation, and capital V is nothing but I into capital R. So I can be written as capital V by R as well. So over here what we have is this capital R from denominator ka denominator will come in numerator, and we have epsilon by V minus V by V. So we got the final formula for internal resistance, which is equal to external resistance into EMF of cell divided by potential difference across the terminal of the cell minus 1. I hope the derivation is clear to all. Now let us talk about the important factors that affect the internal resistance of the cell. The very first factor is the surface area of the electrodes. If the area is more, the ions can leave and combine with the electrode very easily. Therefore, the internal resistance over here decreases. Second factor is the distance between the electrode. If the distance between the electrodes is more, definitely the resistance that the ions will face to travel from one terminal to another will be more, and therefore internal resistance is higher. In third wala case, what we have is nature and concentration of the electrolyte. So if the concentration of the electrolyte is higher, then in that case it faces the ions, they faces higher resistance while traveling, higher opposition while traveling, and therefore the internal resistance also increases. And the last factor that we have is the temperature of the electrolyte. If the temperature of the electrolyte is higher, the movement or speed of the ions increases, and therefore the conductance increases, and what happens is the internal resistance decreases. So I hope the concept of internal resistance and the factor affecting it is clear to everyone. Thank you very much.